Hello there. Okay, we meet again. So for today I will discuss on example 5, okay, and 6. Okay, so example 5 is on freefall motion, okay, which will be the projectile motion with the angle of 0. Okay, so that means the object will be moving in vertical direction only lah. Okay, so for example this one, we have a ball thrown from a top of a building. Okay, so initial velocity over here is given. Okay, let's go back to the previous. Okay, so over here initial velocity given as 10 meter per second. Okay, so whatever information given, derive out the information lah. Okay, so this will be your U. Okay, and then the building has a 30 meter high, and the ball just misses the edge of the roof on its way down, okay, as shown in figure lah. Okay, so they wanted to calculate the maximum height of the stone from point A. Okay, now let's say if we put a sketch. Okay, so let's say you're on top of a building. So this will be your initial velocity U, which will be equivalent to 10 meter per second. Okay, traveling upward. Okay, once it reaches maximum height, okay, final velocity over here will become as 0 lah. Okay, so the formula or equation which you can apply over here will be V is equivalent to U, okay, minus AT. So we are in Y direction, so just make it as Y component lah. Okay, U Y minus G T. Okay, so initial you already have 10, final you have 0, G which will be constant. Okay, so 0, 10, okay, minus 9.81 T. Okay, so from here we can determine the T taken lah. Okay, time taken, let's say I put it as T1 lah. So determine the value of T. Okay, so once you have the value of T, you can use it to determine the maximum height. Okay, so let's say you're going to use the equation as is equivalent to UT, okay, minus half GT square. Okay, so replace in the equation of the time, so you can use it to determine the displacement over here lah, as, okay, which will be equivalent to maximum height. Okay, and then for question B, okay, this is for question A. For question B, they wanted to determine the time taken from point A to C. So this is your point A, and then it returns. So over here you will have point C. Okay, so the time taken from A to maximum, this is T1. Okay, so the time taken to return also will be the same amount of time, T1. So time taken from A to C, it will be equivalent to the initial time, 2 times T1. Okay, so this is one way of doing lah. Okay, or let us look into this solution. You can straight away apply equation V square U square minus 2GS lah. Okay, so since V, U, G all we have, so straight away apply. Okay, we will end up with the maximum height, okay, 5.10 lah. Okay, I'll prefer for you to try the both of the method, and then compare the answer lah. You should be able to end up with the same final answer. Okay, and then from point A to C, Okay, so this one method, they straight away refer from point A to C. Okay, from A to C, the displacement will be 0. Okay, displacement 0, initial still 10, G constant. Okay, so replace in to find the final answer. Okay, so T you will end up with 2.03 second. So if you do the previous calculation, you will get about 1 point something and then multiply by 2. Okay, so this one we have two method. Okay, try the both method lah. Okay, now for C. Okay, so for C from point A to D. Okay, so you refer from point A to D. Okay, so the displacement will be negative 30 meter. Okay, negative 30 meter. So we can use the equation as is equivalent to ut minus half gt square. Okay, so replace in the value. So this one you will end up with quadratic equation. Okay, so quadratic equation, you need to use quadratic equation solver lah. Okay, so you can rearrange in terms of A, B and C. Okay, so from there we can determine the value of T. Okay, negative B plus minus B square minus 4AC root value, okay, over 2A. So solve it, you will have two answer. Okay, so we will choose 3.69 second. Okay, because time don't have a negative value. Okay, okay, so done ready. A to D. Okay, next they wanted to determine the time taken, okay, from A to D given velocity when it reaches point D. Okay, so to calculate the velocity, okay, we can straight away use the equation V U minus GT. Okay, we already have the time calculated, so straight away replace in the value lah. Okay, so initial, so which will end up with negative 26.2. Okay, the reason why we have negative is that at point D, the object is moving downward. Okay, so downward, that means you will have negative velocity. Okay, so this is one way of doing, or what you can do is that you can use the total displacement from point A to D. Okay, so replace in this equation V square U square minus 2GS. Okay, so where V will be the final velocity which we are going to determine over here. Okay, U 10 to G. Okay, S will be negative lah because it is moving downward. Okay, so solve it, you will end up with 26.2 meter per second. Okay, so you'll need to indicate the direction which will be moving downward. Okay, done. So let us look into example 6. Okay, okay, so for example 6, okay, you have a diagram. Okay, figure 2.12 shows a ball thrown by Superman. Okay, initial speed given 200 meter per second and makes an angle 60 to the horizontal. Okay, angle over here given ready. Determine the position of the ball and the magnitude and direction of its velocity when time given as 2 seconds. Okay, and then question B, time taken for the ball to reach maximum height. Okay, and calculate the value of the maximum height lah. Okay, so they wanted to determine the time and maximum height. Okay, C, horizontal range. Okay, D, magnitude and direction of the velocity when the ball reaches the ground at point P. Okay, and then E will be the position of the ball and magnitude of direction of the velocity at point Q. Okay, if the ball was hit from a flat topped hill, okay, with the time at the point of Q is 45 seconds. So this one, that means the ball is traveling further lah. Okay. Okay, so for solution, okay, first thing what you need to do is that you need to break it into x and y component. Okay, so x component will be u cos theta. Okay, so which you solve it, end up with 100 meter per second. Okay, y component will be u initial sine theta, which you solve it, you'll end up with 173. Okay, now for the first question, okay, position when time is given as t. Okay, so to determine the position, okay, for horizontal component, x component, okay, ux times with t. Okay, since for x component velocity will be constant, okay, which will be 100 lah, okay, multiply with t, so you will end up with 200 meter from point O, that means from initial point. Okay, whereas for the vertical component, okay, so this one will be the under influence of gravity g. So we will use the equation sy uyt minus half gt square. So replace in the value of t, which will be 2 over here. Okay, so you will end up with 3 to 6 meter, okay, above the ground. Okay, so therefore the position will be 200 and 3 to 6. So this one will be displacement in x, displacement in y. Okay, so this one we provide position like the coordinate lah, okay, x and y. Okay, now for problem second one. Okay, so they want it to calculate the magnitude and direction of the ball velocity. Okay, t 2 seconds. Okay, horizontal component. For x, velocity will be constant. So that means you don't need to calculate lah. Okay, so your vx will be equivalent to your ux, okay, which will be 100. Okay, whereas for vertical component, yes, this one we need to calculate. Okay, so time already given, so just replace in the value of 2. Okay, so which will end up with 153 meter per second. Okay, so for this one you need to be careful, because when an object doing a projectile motion, okay, once it reaches maximum height, it will change direction. Okay, so later as we discuss the maximum height, we will look into this lah. Okay, so now let's say this is the maximum height, okay, somewhere over here. Now your object is somewhere around here, so that means you will have x and y component. So over here the y component is acting upward lah. Okay, so now that we have the x and y component, okay, you can determine the magnitude and direction lah. Okay, so magnitude, okay, x square plus y square over root value, so which you end up with 183, and then angle tangent theta, which will be ratio of y over x. Okay, so which you get 56.8, okay, from the x-axis lah, or above the x-axis. So that means this is how your resultant vector will look like. Okay, so this is your vx, vy, okay, this is your resultant velocity and your angle theta over here. Okay, okay, now for maximum height. Okay, the condition for you to get maximum height is that velocity of y component becomes 0. Okay, so now we have the condition. Okay, so we can calculate the time taken. Okay, so y component vy final velocity becomes 0, Okay, initial 173. So we can determine the value of t. Okay, so once you have the value of t, you can calculate the displacement, okay, which will be the maximum height. Okay, so just replace in 17.6 over here. Initial velocity given or already calculated at the beginning. Okay, so we end up with 1525 meter. Okay. Okay, done ready. Question B. Okay, now for question C. Okay, see the horizontal range. Okay. So let's say you have a flat surface. Okay. So object makes a projectile motion. Okay, so when it makes the projectile motion, the time taken over here. Okay, let's say T1. This one will be equal in magnitude lah. Okay, so this is your starting point, this is your ending point. Okay, so the time taken for the half of the projectile motion will be equivalent. Okay, so that means over here, let's say the amount of T1, once it reaches maximum height, return back to displacement 0, the time taken will be equal lah. Okay, so since previous one we already calculated the time taken for it to reach maximum height, so you can just simply multiply it by 2. Okay, so this one will be the time taken for it to complete the range lah. Okay, so now we have the time taken to calculate the range. Okay, total displacement, initial point up to final point. Okay, displacement x. Okay, so initial velocity multiplied by total time taken, so which will end up with 3520 meter. Okay. Next question. Okay, when the ball reaches point P, they want you to calculate the magnitude and direction of velocity. Okay, so this one over here, the displacement will become 0. Okay, so x component will be constant. You know, no need to calculate lah this one over here. Okay, so you just need to calculate the y component. Okay, so calculate for y component. Okay, v equivalent to u minus gt. So this one you will end up with negative 172 meter. Because when it reaches point P, the velocity will be acting downward. Okay, so y component downward, u component still constant lah direction. So the resultant will be somewhere situated over here lah, with angle theta. So basically for calculation like this, okay, so your initial and final, you will end up with the same velocity lah. Okay, with same angle. Okay, so solving this further, find the magnitude. Okay, so you end up with 200, right? So which will be equivalent to your initial. So the angle also, if you calculate, you will end up with the same angle. Okay, which will be 60. But over here you have negative, because the angle is acting downward lah. Okay, downward below x-axis. Below positive x-axis. Your theta will be over here. Okay, so if provided in rotation, so that means this one will be 300 degrees lah. Okay, now the last one, point O. Okay, to Q, 45 seconds. Okay, so 45 seconds, that means it has passed through point P lah. Okay, moving further down. Okay, so since the T is already given, we can determine the position. Okay, so position, calculate back. Okay, value of displacement x and the value of displacement y. Okay, so displacement x you get 4500. Okay, so for y you will end up with negative 268 meter. Okay, so this one will be below the ground, so that means below the initial position. Okay, so now the situation is like this. Okay, point O, and then you have point P over here, right? Now what happened is that the object misses point P and traveling further down. Okay, so this will be point Q. So for point Q, velocity y downward. Okay, this will be velocity x lah. Okay, so from reference, so this will be your new position lah. Okay, so from reference, so that means from O. Okay, this will be S x. Okay, from reference O. Okay, this will be S y. Okay, S y will be negative because it is below the ground. Okay, so we have done this. What we can do is that, okay, now we can move on to calculate the position. Okay, gotten ready. Okay, magnitude and direction of the ball. Okay, so horizontal component constant, vertical calculate again by using the time given, so which will end up with negative 269 meter per second. Okay, from there we can determine the magnitude. Okay, resultant velocity, which will end up with 287 meter per second. Okay, so basically once it passes the initial reference point, the velocity will increase lah. Okay, velocity will increase but in opposite direction. So that means the resultant you will end up with a higher velocity, okay, compared to point P. And then direction, calculate the ratio of y and x component. So the angle over here you get 69.6. Okay, below lah. Okay, below positive x-axis, or if you use a rotation you will end up with 290 lah. Okay, alright, so that's all. Have a nice day. Do go through lah, okay, with this example. Hopefully this can help you with your tutorial question.